Here in this question, we want to find, we want to differentiate that function, and then we want to answer where the slope of the tangent line is horizontal or vertical. So in the first step, we just want to differentiate it. So this is an implicit function. So when we differentiate y, we're gonna be dy dx, and then we want to solve for dy over dx. But before that, I'm gonna move to part B. So in part B, ask us what's the values of x or y that gonna result in horizontal or vertical tangent line. So when it's gonna be horizontal in terms of the derivative, that's gonna be when dy dx is 0. This is when we have a horizontal tangent line, and a vertical when dy dx is infinite or undefined, which sometimes means the same thing. So what we want to do now, we want to take this above and solve for dy dx. So what I'm gonna do, I'm gonna take similar term or terms that have dy dx on the left side, and gonna move other terms on the right side. So now what I can do is factor dy dx from these terms. And now I want to end up dy dx, so I'm gonna divide by 2y plus 7 on both sides. And this is dy dx. So now we have to figure out where it's gonna be horizontal and when it's gonna be vertical. So again, it's gonna be horizontal when dy over dx is 0. When gonna be that? When we have the top term goes to 0. Since we have fraction 0 for something, gonna be 0. So the top term equal to 0, and we solve for x, and that gonna be horizontal when x equal to 2. Now the tangent line slope gonna be vertical when we have the bottom term is 0. Why? Because if we have a fraction and we have something over 0 that is goes to infinity, or it's undefined. So now we just solve for y. So it's gonna be 2y minus 7, and then y gonna be minus 7 over 2, and that is when the tangent line is vertical.